Heat exchangers are an extremely common and useful piece of equipment in the mechanical engineering world. They transfer energy between two fluids through the use of heat. Some uses for heat exchangers include heating up a colder fluid, cooling down a hot fluid, boiling a liquid using either another hot liquid or a hot gas, or condensing a gaseous fluid. In most cases, heat exchangers do not allow the two fluids to come in contact with one another. This is because the fluids will be returned to the larger system the heat exchanger is a part of and would contaminate one another. However, direct contact heat exchangers do allow the mixture of the two fluids. Some heat exchanger styles include shell and tube heat exchangers, U-tube heat exchangers, plate heat exchangers, adiabatic wheel heat exchangers, fin tube heat exchangers, and direct contact heat exchangers. When learning about heat exchangers, I always had trouble visualizing how the two fluids didn't come in contact with one another, so I built a see-through model to demonstrate what would be happening in a larger system. This is a simplified example of a shell and tube heat exchanger. It contains one pipe inside the other. It can also be referred to as a tube and tube heat exchanger. Shell and tube heat exchangers can have many tubes running through them. This example just has one. For practical use, this would normally be made of metal since metal has a better thermal conductivity than plastic. Thermal conductivity is a material's ability to transfer heat. This example is made of PVC plastic to show the flow through the system and demonstrate that the two fluids don't touch. The most difficult part of this build was making sure the ends of the outer pipe were sealed properly around the inner pipe. Since I ran the system at a pretty low pressure, I didn't have any leakage once all the connectors were tightened properly. I glued all of the PVC connections and used plumber's tape on the metal-to-metal connections. I ran the system with counterflow, meaning that the hot fluid flowed one direction and the cool fluid ran the opposite direction. Typically, the flow through a heat exchanger would be provided by the larger system it's a part of, but for this example, I powered my system with two identical pumps. The pumps provided about a gallon a minute of flow. The downside to the pumps I chose was the limited amount of head they were able to provide. The pumps only had the ability to provide about 3 feet of fluid head, that is, lift water 3 feet off the ground. Because of this, I built my system about 2 feet off the ground. Both the liquids in my system were water, with the water in the inner tube dyed green with food coloring to make it easier to see. Unfortunately, my system didn't end up showing any measurable heat transfer. I was working in a garage in 35-degree weather and couldn't keep the buckets of water at different enough temperatures to maintain steady-state conditions. My system had steady flow conditions, but the water temperature in the hot buckets dropped rapidly from the ambient air, not from heat transfer between the two fluids. However, I did reach my goal of demonstrating opposing flow and demonstrating that the two fluids don't touch. If there had been any leakages between the tubes in my system, I would have been able to see the green dye leaking into the outer tube, and this didn't happen. I hope now you've got a better understanding of how tube and tube heat exchangers work and are able to visualize that process.